Hi, I am Arul Jothi, working as Assistant Professor in the Department of Computer Science, Fatima College, Madurai. Today, we are going to discuss greedy method strategy in computer algorithms. In algorithm, we have several strategies to solve a problem and to get the maximum limit or minimum limit. Here, we are going to discuss greedy method strategy. So in this, we search for, like a greedy method, we search for several solutions to a problem. All the solutions here are referred to as feasible solutions. And out of this, we have to find an optimal solution. For this strategy, today we are going to discuss about knapsack problem. So in knapsack problem, we have a sack that have a maximum capacity also there. We have to fill the sack with the maximum profit, and we have a maximum limits of the stack, how much weight it can hold. So within that weight also we have to fill the object, and the profit should be maximum. So in this, maximum profit, if it is attained, then it is the optimal solution. So first of all, we can discuss about what is an algorithm. An algorithm is a self-contained step-by-step set of operations to be performed. An algorithm performs several calculations, data processing, and automated reasoning tasks. So here is our knapsack problem. Here in this diagram, a sack is shown. The maximum limit of this sack is given as 15 kg, and there are 5 objects around it of different weight and profit. Profit is given in dollars and weight in kgs. So we have to fill the sack with maximum 15 kg limit, and to attain a maximum profit is our optimal solution. So this given set of items are holding weights and profit values, and we have to fill it without exceeding the limit. Here is the knapsack problem. Here n refers to the number of objects and w is the weight, p indicates the profit, and m is the maximum capacity of the sack, and x is the fractional values of the objects that is going to be filled with. Usually x value varies from 0 to 1, and mostly its value is 1 or a fractional value. Sometimes it is 0. Okay, so this is the given information since knapsack problem. We have to attain our maximum profit with the help of these values. So maximize profit subject to the weight should be less than m, and x is a fractional value that varies from 0 to 1, and n is the number of objects. So I varies from 1 to number of objects. And next, these are the steps to be handled in knapsack problem. Consider all the items with their weight and profits mentioned respectively. Calculate this Pi by Wi. So I have calculated in the next slide the solution to a problem with an example. I handled with 4 logics or strategies to this problem, and the maximum profit I attained when I calculated Pi by Wi for the items and sort the items in descending order based on their Pi by Wi values. And I have to also be careful that without exceeding the maximum limit, I have to fill the sack, and it can store fractional values also. So sometimes it is referred to as fractional knapsack problem. So this is an example I have tried with. This is a knapsack problem. Here I have taken n as 3. So n is the number of objects and m is the capacity of the sack, that is 20. P1, P2, P3 are the profits, the corresponding objects, and W2, W3 again weight. So I tried 4 feasible solutions. So first one, any fractional order, that is randomly I have taken 1 by 2, 1 by 3, 1 by 4 for x. And second one with maximum profit. So out of this maximum profit, 25 is the maximum profit, which is for object 1. So I have filled the value of object 1x as 1. So weight of this first object is 18. So maximum size is 20, sack size. So 20 minus 18, remaining 2 only I can fill with the other items. So remaining 2 is filled for the next maximum profit. That is second object. Its weight is 15. So 2 by 15 is the next fraction available. And all 20 kgs I have filled. So remaining I have to fill with 0 and less weight. So here I have to fill the object which is having less weight first. So less weight means in a weight array we have a third value 10, which is the minimum weight. So we have to fill the minimum weight object with 1. And next minimum is 15, second object, that is filled by the remaining value. So 10 is filled out of 20. So 20 minus 10, 10. So 10 by 15 will be filled for the second one. So 10 by 15 is 2 by 3. So this is, and the remaining with 0. And the last one is in the order of PIWI. So that calculation is calculated in the next sheet. The first 3 we can discuss with the fractions. By into 18. So I have this summation of WIXI as 16.5, which is less than our maximum limit, that is 20. And next profit is 24.25. And next one is second, the maximum profit fractions. That is object is weight is 20, again within the limit only. Next its profit is 28.2. So that is little bit greater than the first method. And third one, again I have calculated, its profit is 31. So again it's much better than the other methods. The final strategy is PIWI. So I am going to arrange the objects in the order of the weight, that is PI by WI. So PI by WI for all the 3 objects I am calculating. So first I have to again sort it out. So first 1.6 for second object. So second object I have to place first, and next one third, and finally only first object. If we arrange the objects in this order 2, 3, 1, then I will get the optimal solution. So decreasing order. So first I have filled second object with 1, and the remaining with the next increasing 1/3. So its weight is first object's weight, second object's weight is actually 15. So 15 is filled. So remaining 5 weight for the third one, that is 5 by 10, again 1 by 2. So I am calculating again the weight and profit. My weight is within 20 only, and my profit is 31.5, which is greater than all the other 3 strategies. So this is my optimal solution out of the 4 feasible solutions. Okay, next we have an algorithm to calculate the fractions values of the knapsack method. So greedy knapsack. Here I am going to get the fractional values with the final strategy, that is PI by WI in the increasing order. So first I have to assign 0 to all the x values, then the maximum capacity and M to CU, and I have to each and every time I have to check whether the weight is greater than our maximum capacity. If it is okay, then we have to place 1 to the x value, and we have to subtract the remaining values weight from the maximum capacity. So I have to repeat the process unless I finish all the items filling. So this algorithm is also executed here. Here we have this arranged in ascending order in the order of PI by WI, and P1, P2, P3 I have values 24, 15, 25, and W1 is again I have arranged this in the order of PI by WI. After that I have filled all the 3 x values by 0, and first I have to fill the first object with 1, and I have to subtract its weight. 20 minus 15 I have 5. I have to fill it with the remaining second object 5 by 10, that is 1 by 2, and the last one with 3. So third object with 0 value. So 1 by 2, 0 is my fraction. So in this way, if we calculate the fractions and summate the value, I get the maximum profit, that is 31.5, which is my optimal solution. So in this fractional knapsack problem today, we find a method to find an optimal solution out of several feasible solutions with the help of this greedy approach. The time complexity of this algorithm is big O of n log n, and its space complexity is big O of n. Thank you.